Hi everyone. This is our lecture video for section 2.3. We're not going to be working on problems from this section. We're just going to talk briefly about the material from this section that we need for our future sections. Tomorrow, that is on Tuesday, September 8th, we will be lecturing on section 2.4. In this section, section 2.3, you are dealing with the approximation of trigonometric function values. The material involved with this section and from here on forward, you're going to want to use your graphing calculator to tackle some of these problems. A scientific calculator will suffice until you have one, but it is advisable that you grab a graphing calculator. You're also going to need one for pre-calculus as well, if you decided to take that class. You're also most likely going to need a graphing calculator for Calculus 1 and Calculus 2. So for trigonometric functions, you will want to remember the following. The input of a trigonometric function is an angle theta associated with a right triangle. The output of the trigonometric function is a ratio of two sides of a right triangle. Which two sides those are will be dependent upon the trigonometric function. So for example, for sine of theta, the sine of theta is equal to the opposite over the hypotenuse, or y over r. Now, is there a function that goes backwards? A function where I plug in a ratio and its output is an angle theta? The answer is yes. This section 2.3 will introduce you to inverse trigonometric functions. We're just going to be talking very briefly about the inverse sine, inverse cosine, and inverse tangent. Inverse trigonometric functions, they have their own notation associated with them. They're usually written as the trig function with the exponent of -1. This is not the same thing as writing it as 1 over the trig function. Please keep that in mind. Okay, so I did write that here in these notes. This notation is used specifically for inverse trigonometric functions. Now, we're not going to be talking about these functions in detail. We will do so in later chapters. For now, what do you need to know about them? The domains and ranges are listed here. The way inverse trigonometric functions work is your input is a ratio of a right triangle and its output is an angle. For a lot of these problems, the ratios will be simplified. And we're going to be using a graphing calculator for a lot of these evaluations. So you're going to want to remember the following. So for a trig function, I plug in an angle. My output is a ratio of two sides of a right triangle. Inverse trigonometric functions, they are maps that go in the opposite direction. For an inverse trigonometric function, you're going to plug in a ratio of two sides of a right triangle. Which two sides those are will be dependent upon the inverse trig function. Your output will be an angle. For a lot of these problems, the ratios themselves will be simplified. Something else to note here is that the range of an inverse trigonometric function, it has a specific restriction, and we will talk about that restriction in later chapters. And I also just now realized I actually have a typo in these notes. I need to fix that now. I am so smart sometimes. So inverse sine, the range of inverse sine is -90 degrees to 90 degrees inclusive. For inverse cosine, the range is from 0 degrees to 180 degrees. For inverse tangent, it is from -90 degrees to 90 degrees exclusive. So for these problems that we have here, you are asked to use a calculator to evaluate each of the following expressions. make sure your calculator is in degrees. A lot of the problems that you see here, if we just look at the trig functions, the angles that are given, a lot of the angles are not the super special values that we have on the unit circle. If we look at the inverse trigonometric functions, a lot of the ratios that are there, a lot of them are not super special values on the unit circle. You can go ahead and use your calculator for these problems, and I'm going to show you how to do that with my TI-84 calculator. So for number 1, I have to type in sine of 83 degrees. It says here to make sure that your calculator is in degree mode. So I'm going to do that first with my calculator. I'm going to hit the mode button. You see where it says radian and degree? I need to change that from radian to degrees. Radian is another unit for angles that we will talk about in the future. And now going back to my problem, I need to type in sine of 83 degrees. So I hit the sine button, I hit 83, I hit enter. Now for these problems, it says to round to 3 decimal places, so my answer will be 0.993. Up next, we have cosine inverse of 0.45. Now remember that for inverse trigonometric functions, your input is a ratio of 2 sides of a right triangle, and your output is an angle, okay? Those ratios might be simplified, right? 0.45 is a simplification of a ratio. So for my calculator, I have to hit the second button and then hit the cosine button to get cosine inverse. Then I hit 0.45 there. Rounding my answer to 3 decimal places, I have 63.256 degrees. The next one we have tangent of 16 degrees, 0.287 as my answer. And from here, I could leave it to you to do the rest. As I said before, you're not going to have homework from this section. You do need to read these notes and keep these inverse trigonometric functions in mind for when we work on section 2.4 tomorrow. That's going to wrap it up for today's lecture video, and I will see you tomorrow in class.